Hi, today we're going to be learning about proportion. We're going to start off by looking at what direct proportion is. When two variables are directly proportional to each other, they have a constant rate. So for instance, if your two variables are distance and time, then the rate of distance versus time is speed. If the two variables are directly proportional, that means that you have a constant speed. Okay. If your variables are x and y, and if they are directly proportional to each other, then if you take the one variable and you divide it by the other variable, you will get a constant. No matter what the value of the first variable is, if you divide it by the value of the second variable, you'll always get the same answer, the same constant. Okay. If the one variable, x, increases, then the other variable, y, will also increase in the same proportion. And if the one variable, x, decreases, then the other variable, y, will also decrease in the same proportion as well. If x, the one variable, is equal to 0, then the second variable, y, will also be equal to 0. And the relationship between the two variables, x and y, can be represented by a straight line graph that passes through the origin like this. So if we plot points for all the corresponding x and y values, they will form a straight line graph like this that goes through the origin. Now it doesn't have to go at exactly 45 degrees. It can be a steeper graph. If it's a steeper graph, it means that you have a different constant value, and it can be a less steep graph like that as well, and then your constant is just going to be a different value. Okay, so let's have a look at an example. In this example, Jerem and Keegan each went for a walk. The table below shows the distance they had covered at different times. So you can see over here, after 25 minutes, Jerem had covered a distance of 1,500 meters, and after 40 minutes, he had covered a distance of 2,400 meters. If we look at Keegan, then after 25 minutes, he had gone 1,600 meters, and after 40 minutes, he had also gone 2,400 meters. Okay, so using the data that's been provided, we need to determine whose time and distance are directly proportional to each other. In order to work out if the time and distance are directly proportional, we need to find out if, when we divide the one by the other, we get a constant. Okay, so now let's have a look at how we would do this question. So first of all, I'm going to be working with Jerem and Keegan separately. I'm going to work out if Jerem's time and distance are directly proportional, separately from working out if Keegan's distance and time are directly proportional. When I want to work it out, like I said, we're going to take the one variable and divide it by the other one and see if we get the same result. I need to be consistent in the way that I do this though. I can choose if I want to divide distance by time or if I want to divide time by distance. I'm not trying to work out speed specifically. If I was wanting to work out the speed, I would have to do distance divided by time, because that's how you work out speed. But in this case, I'm not being asked to work out the speed. I'm just being asked to work out if the two variables are directly proportional. In order for them to be directly proportional, when I divide the one by the other, I have to get a constant. Okay, so what I need to do is I can choose to divide distance by time, or I can choose to divide time by distance, as long as I'm consistent in the way that I do it. Okay, so I'm going to divide the distance by the time. So first of all, I'm looking at Jerem. Okay, so for Jerem, the first measurement that I've got is at 25 minutes. He had walked 1,500 meters. So I'm going to say his distance, which is 1,500, divided by his time, which was 25 minutes. And I'm going to work that out. So 1,500 divided by 25 gives me 60. So that is 60 over there. So that's for the first data set that I have for Jerem. Now let's have a look at the second data set. At 40 minutes, he had gone a total of 2,400 meters. So 2,400 divided by 40. And let's work that out. Okay, so 2,400 divided by 40 gives me 60 as well. Okay, so now I've done my calculations for Jerem. We're still going to come back and do our conclusion. Now let's quickly do the same thing for Keegan so we can compare them. Okay, so for Keegan, I'm going to do the exact same thing. I'm going to take the distance and divide it by the time for each data set. So at 25 minutes, he had traveled 1,600 meters. So I'm going to say 1,600 divided by the 25. Okay, so over here, 1,600 divided by 25, that gives me 64. Okay, and then over here, I've got at 40 minutes, he had also gone 2,400 meters. So the second one is going to be 2,400 divided by 60, or divided by 40, sorry. And that gives us 60, just like we had over there, because it's exactly the same. Okay, so now let's go and compare these. So for Jerem, when I take the distance and I divide it by the time, I got 60 for both data sets that I have for him, both measurements that I have for him, I got the same value, so it's constant. But for Keegan, when I took the distance and I divided by the time, for the two data sets that I have over here, or the two data points that I have over here, they are different, okay, the two measurements. So now, this is not constant. So what I can say now is that Jerem's distance and time are directly proportional, but Keegan's are not. And the reason I know that is because when I took the two measurements for Keegan and I divided there, I ended up with different results. So it's not constant. That means that it is not directly proportional. So when you get the same result, then you can say it's directly proportional based on the data that you've got. And when you get different results, you can say it's not directly proportional. Okay, now I just want you to take note in this particular example. At the end of the 40 minutes, both Jerem and Keegan had walked the same total distance, okay? Jerem was maintaining a constant speed the whole time. We know that because we can see that the distance and time are directly proportional. That means that he had a constant rate of distance versus time. But Keegan, he was starting out faster. He covered 1,600 meters in the first 25 minutes, an extra 100 meters more than Jerem had covered. But then he must have gotten tired or something because he slowed down and he ended up covering the same distance as Jerem altogether in the 40 minutes. So Jerem and Keegan, they have the same average speed for the full 40 minutes. Keegan also had the same average speed for the full 40 minutes because altogether he traveled 2,400 meters in 40 minutes just like Jerem did. But his speed was varying throughout his trip, whereas Jerem was walking at the same speed the whole time. Okay, now let's go and have a look at what indirect or inverse proportion is. Okay, so if x and y are indirectly or inversely proportional to each other, then what that means is that if you multiply them together, so x and y are our two variables, if you multiply them together, you will get a constant value, the same constant value every time. So when you have direct proportion, you divide the two variables to get a constant. When you have indirect or inverse proportion, you multiply the two variables together to get a constant. Okay? As x increases, y decreases. So as the one variable increases, the other variable decreases. And as x decreases, y will increase. So as the first variable decreases, the second variable will increase. So your two variables are doing opposite things. As the one goes up, the other one goes down. Okay, whereas with direct proportion that we were just looking at before, if the one goes up, the other one goes up. So they both do the same thing. They will both go up or they will both go down. But with indirect or inverse proportion, they are opposite in the way that they behave. If the one goes up, the other one will go down. Okay. X and Y, the two variables, can both not be equal to 0. Neither of them can be equal to 0. Okay, it's just not going to work. And the relationship between the two variables can be represented by a non-linear graph like this over here. Okay, so you can see over here it's non-linear. That means it's not a straight line. Okay, and as it gets closer to the y-axis or as it gets closer to the x-axis, it's going to be going more and more, in this case over here, more and more steep, in this case less and less steep. It's going to always stay away from the y-axis and stay away from the x-axis. It's not going to bend away from it completely. It's going to keep on getting closer and closer, but it's never going to reach the y-axis. And it's over here, it's going to keep on getting closer and closer, but it's never going to reach the x-axis. And the reason is because it cannot be equal to, y cannot be equal to 0 and x cannot be equal to 0. Okay, so that's what your graph would look like. If you were to represent the relationship between these two variables, it would look like that. Okay, so now let's have a look at an example. It takes 8 workers 12 hours to complete a job, and it takes 16 workers 6 hours to complete the same job. Are the number of workers and the time directly proportional, inversely proportional, or neither? Okay, so now let's have a look at how we would do a question like this. So in this example over here, we've been given a situation where there's a job that's being done, and we have different number of workers that could be available to do the job, and as more workers do the job, the time that it takes to do the job decreases. Okay, so the first thing we need to do, if we need to work out if these variables are directly proportional, inversely proportional, or neither, the first thing we need to do is identify what is it most likely to be. Is it most likely to be directly proportional, or is it most likely to be inversely proportional or indirectly proportional? To work that out, we'd look at the two variables. The two variables are the number of workers and the time. And we see if the one increases, what's happening to the other one. So if I look at the number of workers, if the number of workers increases from 8 to 16, what happens to the amount of time it takes? The time goes from 12 down to 6. So if the number of workers increases, the amount of time decreases. So they're doing the opposite, which means that it cannot possibly be directly proportional, because if it was directly proportional, they would both be going up or they would both be going down. Okay, so the first thing we're going to do is identify which it could be. Could it be directly proportional or could it be inversely proportional? Based on the fact that the one variable is going up and the other one's going down, we can say that it could be inversely proportional. Okay, so I can say that as the number of workers increases, the time decreases. Okay, now what that means for us is that it could be inversely proportional or indirectly proportional. Okay, now that I've identified which of the two it's most likely to be, it can't be directly proportional. I know that because then both variables would have to be doing the same thing, and they're not. The one is going up, the other one's going down. So it can only be inversely proportional or neither. Okay, so now I've got a theory. My theory is that these two variables could be inversely proportional. Now I need to go and check my theory. So what I'm going to do is I'm going to, just like I did in the previous example, I'm going to go and check the two measurements or the two sets of values, and I'm going to see if it works out to a constant amount. in this case, because I'm working with what I think is going to be inversely proportional, I'm not going to be dividing them, I'm going to be multiplying them. Okay, so over here I'm going to say the number of workers multiplied by the time. So for the first set, I've got 8 workers and 12 hours. So I'm going to multiply 8 by 12, and that will give me 96. Okay, so that's my first set. Multiply the number of workers by the time. That gives me 96. Then the second set, I've got 16 workers. So 16 multiplied by the time, which is 6. Okay, so 16 times 6, and that also gives me 96. So now, because I get the same answer when I multiply the number of workers by the time for the first set and the number of workers by the time for the second set, I can now say, because I got the same answer, it's constant. Okay, so when I multiply the two variables together, I get a constant result. So now I can say, therefore, the number of workers and the time are inversely proportional. Okay, so that's how you can take a question and you can determine whether a set of variables is inversely proportional, directly proportional, or neither. If this had come out as different values and these were not the same, then I would say that it is neither. It's not directly proportional, and it's also not inversely proportional. I knew already that it wasn't directly proportional because they weren't doing the same thing. The one was going up and the other one was going down, so it can't be directly proportional. And then I had to test, and I find out using the values that they gave me, because I was testing for inverse proportionality, I was multiplying the values together and see if I get the same result for both sets. If I get the same result, I can then say that it is inversely proportional. If I get different results, I can say it is not directly proportional, and it is also not inversely proportional, so it is neither. Okay, now you're going to do a few questions for yourself. Here's the first question that you're going to do. 2 bags of groceries weigh 6 kilograms and 5 bags of groceries weigh 10 kilograms. Is the mass of the groceries directly proportional to the number of bags? Okay, so now I'm going to give you 1 minute to work on this question. Okay, so let's go through that question and see what you should have got. So to start off, in this question, they're not asking us to determine if it is directly proportional or inversely proportional or neither. They're already telling us what they want us to test for. They want us to test to find out if it is directly proportional. So that's all we're interested in, okay? So if I look at the variables, it's the mass of the groceries and the number of bags. Those are the 2 variables that I'm working with and I want to find out. So I want to know if they are directly proportional. So to work out if they're directly proportional, we divide them by each other, the one by the other. So I'm going to decide, am I going to divide the mass by the number of bags or the number of bags by the mass? It's generally easier to take the bigger number and divide it by the smaller number. So if you look at the data that we've got over here, the number of bags is 2 and the mass is 6. So the mass is more than the number of bags. So I'm going to be dividing the mass by the number of bags. Okay, so for question A, I'm going to take, for the first example, 2 bags and 6 kilograms. I'm going to say 6, the number of, or the mass, divided by the number of bags is 2. And that gives me 3. So what that means is it's 3 kilograms per bag. Now let's see if it's the same for the other example where we've got 5 bags that weigh 10 kilograms. Okay, so in the second one we've got 10 kilograms is the mass divided by the number of bags, which is 5. Now if I divide 10 by 5, I get 2. Now these are not the same as each other, which means that these are not going to be directly proportional. They would be directly proportional if they both gave me the same number, but they don't. So now I can say, therefore, they are not directly proportional. Okay, so that's what you should have got for question A. Now let's go on to question B. A person walking at 4 kilometers per hour takes 15 minutes to walk a certain distance, and walking at 5 kilometers per hour takes 12 minutes to walk the same distance. Is the speed inversely proportional to the time? So I'm going to give you 1 minute to work on this question as well. Okay, so let's go through that example and see what you should have got. So first of all, in this one, we're being asked to work out if these variables, the speed and the time, are inversely proportional. So when you want to find out if 2 variables are inversely proportional, you're going to be multiplying them together. So I'm going to multiply the speed and the time together for the first set, where the person is walking at 4 kilometers per hour and it takes 15 minutes. Now, just so that you're aware, when you are working out speed, distance, and time, when you're working with rates, then you have to make sure that your measurements are consistent. When we're doing this, we don't really have to worry about that, except that we have to make sure that they are consistent for the 2 sets of data. So if I take the 4 kilometers per hour and the 15 minutes, it doesn't matter that I'm working with kilometers per hour and minutes, so long as the other one is also kilometers per hour and minutes. I can't have kilometers per hour and minutes for the one and kilometers per hour and hours for the other one. They have to be the same in that way. Okay, so the first set is 4 kilometers per hour and 15 minutes. So I'm going to multiply those together. So 4 times 15, and that gives me 60. Then the second set is 5 kilometers per hour, and I'm going to multiply it by the time, which is 12 minutes, and that also gives me 60. Okay, so now, because I got the same result for both, I can say that they are inversely proportional. Okay, so that's what you should have got for question B. Right, now let's go on to question C. So in question C, 1 tap fills a tank in 6 hours, while 3 taps take 2 hours to fill the tank. We need to work out if the number of taps and the time are directly proportional, inversely proportional, or neither. Okay, so I'm going to give you 1 minute to work on this question as well. Okay, so let's go through that example and see what you should have got. So in this question, let's have a look at, first of all, which of the two it could be. Could it be directly proportional or could it be inversely proportional? To work that out, I look and see what's happening with the two variables in comparison to each other. When I increase the number of taps from 1 to 3, what happens to the time? It decreases from 6 to 2. So as the one goes up, the other one goes down. So they're doing opposite to each other. That means it can't be directly proportional. It could only be inversely proportional. So for question C, we're going to start off by identifying that it could be inversely proportional. So as the number of taps increases, the time decreases. So therefore, it could be inversely proportional. It can't be directly proportional. Okay, so once I've identified that, now I know what to do, because when I'm wanting to test if something is inversely proportional, I'm going to be multiplying the two variables together. So I'm going to take the first set of variables, which is 1 tap, which takes 6 hours. So I'm going to be multiplying the 1 tap by the 6 hours, and that gives me 6. The second set is if I have 3 taps, and I multiply that by the time that it takes, which is 2 hours. And that is also 6. So because these both gave me the same result, I can now say that it is inversely proportional. So therefore, they are inversely proportional. Okay, so that's question C. And then the last question for today. Question D. A train travels 150 kilometers in 3 hours and 250 kilometers in 5 hours. We need to work out if the distance and the time are directly proportional, inversely proportional, or neither. I'm going to give you 1 minute for this question as well. Okay, so let's go through that and see what you should have got. So first of all, if you look at your two variables, you've got distance and time. So if we look at working out first if it could be directly proportional or if it could be inversely proportional, let's see what is happening with the two variables in comparison to each other. So if the distance increases from 150 kilometers to 250 kilometers, what happens to the time? The time goes from 3 hours up to 5 hours. So they both increase. That means that it could be directly proportional. So over here, I can say as the distance increases, the time also increases. Okay, which means that it could be directly proportional. So now I need to go and check that, and I need to find out, is it really directly proportional? So what I'm going to do is, when I'm trying to check for direct proportionality, I'm going to be dividing the two variables by each other. So I'm going to divide the distance by the time, or the time by the distance. But in this case, it'll make sense to do the distance divided by the time because the distance is a bigger amount. Okay, so I'm going to say for the first set, it's 150 kilometers and 3 hours. So it's going to be 150 divided by 3, and that gives me 50. And then the second set is 250 divided by the time, which is 5, which also gives me 50. So because I got the same answer when I divided the distance by the time for both sets, I can now say, therefore, they are directly proportional. And that is how you work with direct and indirect or inverse proportion. Now that we've learned the concepts in this lesson, it's important to practice, practice, practice. If you haven't already got the worksheet that goes with this video, you can find it by clicking on the link in the description below. The worksheet comes with an extra exercise full of questions for you to work on to master the concepts covered in this lesson. If you found this video helpful, please hit the like button so that others can benefit from it too. Also, be sure to subscribe so that you can easily find my other lessons, and hit the bell so that you will get notified about lessons as I upload them.